I wanted to provide the following introduction to absolute values to assist those students who struggle with not seeing the visual connection between the algebraic work that we are doing. Now, when you think about absolute value, the definition of absolute value is that it is the distance of a number or an expression from zero on the number line. And I like this definition because it says the distance of a number or an expression. And that's going to help us out visually the further we go. So let's kind of look at what does it mean visually to have the absolute value of x equal to 5. Well, that's where we come up with the idea that this means that x is located 5 units from 0. So our x is located 5 units from 0 on the number line. And so if we start at 0, you can go to the right 5 units, and so here's x. So we know x equals 5. But we can also go 5 units towards the left, towards negative 5. So here's x as well. X is negative 5. So there are actually two answers when solving an absolute value equation. The one where we go towards the positives for the distance, and the one where we go towards the negatives for the distance. So our x is located at negative 5, and our x is located at 5. So if we were to, in a way, say, let's solve this absolute value equation, your answer would be x equals negative 5 or 5, because both of those are 5 units from 0 on the number line. Let's try one that's a little bit harder. It involves applying that same visual technique. This time it says the absolute value of 2x plus 4 equals 8. And so what this means is it means your expression, 2x plus 4, that actual expression is located 8 units from 0 on the number line below. So if we start at 0, we can go over to 8. And so this is where our expression 2x plus 4 is located at. It's located at 8. So 2x plus 4 equals 8. That is one of the equations. But we could also go towards the negative, because that is also, negative 8 is also 8 units from 0. So this means that 2x plus 4 is also located at negative 8. So 2x plus 4 equals negative 8. So those are the two equations that we work with when we're solving the absolute value equation above. The first is that 2x plus 4 is equal to negative 8. So subtract 4, x is negative 12. Divide by 2, x is negative 6. The second is 2x plus 4 equals 8. And so subtract 4, 2x equals 4. And divide by 2, x equals 2. And so our answers, we have two of them. X equals negative 6 or 2. So I hope this technique of looking at the visual connection between the algebraic work that we see down here with the original problem. We need to remember the absolute value is the distance from 0 an object, an expression, or a number is. And so if we can look at it visually here, we see why this absolute value equation breaks down into two separate equations. One equal to the positive of the original, and one equal to the negative of the original. And so that is kind of what we're looking at here. What this whole thing means is that when you're doing the absolute value equation, when you're solving an absolute value equation, first isolate that absolute value by itself. And we're going to look at some problems further on in these videos that show what that means. But isolate the absolute value by itself, and then create two equations, one equal to the original number and one equal to the negative of the original number. I hope that you found this useful.